ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನಾಚರಣೆಯ ಅಂಗವಾಗಿ ಹಮ್ಮಿಕೊಳ್ಳಲಾಗಿರುವ ಇಂದಿನ ಈ ಅರ್ಥಪೂರ್ಣ ಸಮಾರಂಭಕ್ಕೆ ಆಗಮಿಸಿರುವ ಎಲ್ಲ ಮಹನೀಯರಿಗೆ ಹಾಗೂ ಮಹಿಳೆಯರಿಗೆ ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾಲಯದ ಪರವಾಗಿ ಆತ್ಮೀಯವಾದ ಸ್ವಾಗತವನ್ನು ಬಯಸ್ತೇನೆ. ಕಾರ್ಯಕ್ರಮದ ಮೊದಲಿಗೆ ಪ್ರಾರ್ಥನೆ. ಗೀತೆ ಒಂದೇ ಶಾರದೆ, ರಾಗ ಹಮೀರ್ ಕಲ್ಯಾಣಿ, ತಾಳ ಏಕತಾಳ. ಹಾಡಲಿರುವವರು ಲಲಿತ ಕಲಾ ಕಾಲೇಜಿನ ವಿದ್ಯಾರ್ಥಿನಿಯರು. ಬಂಧುಗಳೇ, ಕುವೆಂಪು ಅವರು ನವೋದಯ ಕಾಲದ ಮಹೋನ್ನತ ಕವಿ. ನವೋದಯದ ಪ್ರಮುಖ ಮೌಲ್ಯಗಳಾಗಿದ್ದ ಆದರ್ಶವಾದ, ದೇಶಪ್ರೇಮ, ನಿಸರ್ಗಾರಾಧನೆ, ಧರ್ಮಶ್ರದ್ಧೆ ಹಾಗೂ ಪರಂಪರೆಯ ಬಗೆಗಿನ ಗೌರವ ಇವೆಲ್ಲವೂ ಅವರ ಸಾಹಿತ್ಯದ ಭಾಗಗಳಾಗಿದ್ದವು. ಆದರೆ ಕುವೆಂಪು ಅವರ ಧರ್ಮಶ್ರದ್ಧೆ ಅಂದಾನುಕರಣೆ ಆಗಿರಲಿಲ್ಲ. ಪರಂಪರೆಯ ಬಗೆಗಿನ ಗೌರವವು ಕಂದಾಚಾರಗಳನ್ನ, ಮೂಢನಂಬಿಕೆಗಳನ್ನ ಪ್ರೋತ್ಸಾಹಿಸಲಿಲ್ಲ. ಅವರ ಆದರ್ಶವಾದವು ವಾಸ್ತವಿಕ ಸತ್ಯಗಳ ಮೇಲೆ ಮುಸುಕನ್ನ ಎಳೆಯಲಿಲ್ಲ. ಕುವೆಂಪು ಅವರು ತಮ್ಮ ಕಾಲಮಾನದ ಎಲ್ಲ ಮೌಲ್ಯಗಳನ್ನ ವೈಚಾರಿಕತೆ ಹಾಗೂ ವೈಜ್ಞಾನಿಕ ದೃಷ್ಟಿಯ ಪ್ರಖರ ಬೆಳಕಿನಲ್ಲಿ ಕಂಡಂತವರು. ವಿಜ್ಞಾನ ದೀವಿಗೆಯನ್ನ ಹಿಡಿಯ ಬನ್ನಿ ಎಂದು ವಿಚಾರ ಕ್ರಾಂತಿಗೆ ಆಹ್ವಾನವನ್ನ ನೀಡಿದಂಥವರು. ಈಗ ತಮ್ಮೆಲ್ಲರ ಸಮಕ್ಷಮ ರಾಷ್ಟ್ರಕವಿ ವಿರಚಿತ ನಾಡಗೀತೆಯನ್ನು ಪ್ರಸ್ತುತಪಡಿಸಲಾಗುವುದು. ಈ ಸಂದರ್ಭದಲ್ಲಿ ಸಭಾಸದರು ಎದ್ದು ನಿಲ್ಬೇಕಾಗಿ ವಿನಂತಿ.
जय भारत जननीय तनुजाते, जय हे कर्नाटक माते, जय सुरलनाडे, जय हे रबीडे. ಭೂದೇವಿಯ ಮಕುಟದ ನವಮಣಿಯೇ, ಗಂಧದ ಚಂದದ ಹೊನ್ನಿನ ಗಣಿಯೇ, ರಾಘವ ಮಧುಸೂದನರವತರಿಸಿದ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ. ಜೋಗುಳ ವೇದದ ಜೀವವು ನಿನ್ನಾವೇಶ, ಹಸುರಿನ ಸಾರೆ ನಿನ್ನಯ ಕೊರಳಿನ ಭಾರತ ಜನನಿಯ ಜಾತೆ ಶಂಕರರ ಮನುಜ ವಿದ್ಯಾರಣ್ಯ ಬಸವೇಶ್ವರ ಮಧ್ವರ ದಿವ್ಯಾರಣ್ಯ ರನ್ನ ಷಡಕ್ಷರಿ ಪೊನ್ನ ಪಂಪಲ ಕುಮಿಪತಿ ಜನ್ನ ಕುಮಾರ ವ್ಯಾಸರ ಮಂಗಳಧಾಮ ಕವಿ ಕೋಗಿಲೆಗಳ ಪುಣ್ಯಾರಾಮ ನಾನಕರಮಾನಂದ ಕಬೀರರ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ತೈಲ ಡಂಕಣ ಜಕಣರ ನೆಚ್ಚಿನ ಬೀಡೆ ಕೃಷ್ಣ ಶರಾವತಿ ತುಂಗ ಕಾವೇರಿಯ ವರರಂಗ ಚೈತನ್ಯ ಪರಮಹಂಸ ವಿವೇಕರ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಸರ್ವ ಜನಾಂಗದ ಶಾಂತಿಯ ತೋಟ ರಸಿಕರ ಕಂಗಳ ಸೆಳೆಯುವ ನೋಟ ಹಿಂದೂ ಕ್ರೈಸ್ತ ಮುಸಲ್ಮಾನ ಪಾರಸಿಕ ಜೈನರುದ್ಯಾನ ಜನಕನ ಹೋಲುವ ದೊರೆಗಳ ಧಾಮ ಗಾಯಕ ವೈಣಿಕರ ರಾಮ ಕನ್ನಡ ನುಡಿ ಕುಣಿದಾಡುವ ಗೇಹ ಕನ್ನಡ ತಾಯಿಯ ಮಕ್ಕಳ ದೇಹ ಭಾರತ ಜನನಿಯ ತನುಜಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ ಜಯ ಹೇ ಕರ್ನಾಟಕ ಮಾತೆ.
ಪ್ರಾರ್ಥನೆ ಹಾಗೂ ನಾಡಗೀತೆಯನ್ನು ನೆರವೇರಿಸಿದ ಕುಮಾರಿ ಕಲ್ಯಾಣಿ, ಕುಮಾರಿ ಮಾನಸ, ಕುಮಾರಿ ಪ್ರಣತಿ ಮತ್ತು ಕುಮಾರಿ ಆನ್ಸಿಲಾ ಅವರಿಗೆ ಧನ್ಯವಾದಗಳು. Members of the audience, today we are privileged to have with us Professor N.K. Loknath, the 26th Vice Chancellor of the University of Mysore. Professor Loknath's academic pursuit is a story written in the language of light and matter. In the intricate dance of atoms and molecules, he sees patterns invisible to the ordinary eye. Through X-ray crystallography, he has unveiled over 1,500 crystal structures, including the delicate architecture of 90 proteins. What sets Professor Loknath apart is not just the volume of his accomplishments, but the profound impact of his work on the global scientific community. His research has graced the cover pages of high-impact peer-reviewed journals and has been cited thousands of times by researchers worldwide. Yet, beyond these remarkable achievements, Professor Loknath embodies a rare combination as a leader who shapes institutions and as a mentor who nurtures individuals. Under his guidance, the University of Mysore has championed initiatives like Green Campus, Clean Campus, and Fit Campus, reflecting his vision of holistic development. It is now my distinct honor to invite the Honorable Vice Chancellor to deliver the welcome address.
ಎಲ್ಲರಿಗೂ ನನ್ನ ನಮಸ್ಕಾರಗಳು. ಮೈಸೂರು ವಿಶ್ವವಿದ್ಯಾಲಯದ ಎಲ್ಲ ಅಧಿಕಾರಿ ವರ್ಗದವರೇ, ಮಾನ್ಯ ಸಿಂಡಿಕೇಟ್ ಹಾಗೂ ಶಿಕ್ಷಣ ಮಂಡಳಿ ಸದಸ್ಯರುಗಳೇ, ಎಲ್ಲ ನಿಕಾಯದ ಡೀನರುಗಳೇ ಹಾಗೂ ಗಣ್ಯರೇ, ಬೋಧಕ ವರ್ಗ ಮತ್ತು ಬೋಧಕೇತರ ವರ್ಗದವರೇ, ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಸಂಶೋಧಕರುಗಳೇ, ಆಹ್ವಾನಿತರೇ ಮತ್ತು ಮಾಧ್ಯಮ ಮಿತ್ರರೇ, ತಮಗೆಲ್ಲರಿಗೂ ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನದ ಶುಭಕಾಮನೆಗಳು. Before I introduce our distinguished guest, Dr. V.K. Manchanda, let me talk about the significance of Science Day celebration. National Science Day marks the discovery of the Raman effect by Sir C.V. Raman on 28 February 1928, a breakthrough that placed India firmly on the global scientific map. Sir C.V. Raman became the first Asian to win the Nobel Prize in Physics, demonstrating that world-class scientific research could emerge from Indian soil during the colonial era. His discovery of the Raman effect revealed how light changes wavelength when it passes through a transparent material. Raman proved that groundbreaking research could be conducted with modest equipment but immense intellectual rigor, inspiring generation of Indian scientists to pursue excellence despite the constraints. He strengthened and also led the Indian Institute of Science and later founded the Raman Research Institute, Bengaluru, nurturing research culture in India. Behind his discoveries, Raman was a passionate teacher who believed that curiosity-driven research and fearless questioning were the lifeblood of scientific progress. From ancient mathematical brilliance to modern space exploration, this day reminds us that India's scientific tradition is both deep and dynamic. National Science Day reinforces us our constitutional duty to promote scientific temper. This day serves as a powerful catalyst to ignite curiosity among students, encouraging them to question, explore, experiment, and innovate. Science Day is an occasion to celebrate the contribution of scientists, researchers, students, innovators who propel knowledge for societal progress. Scientific research definitely drives economical growth, technological advancement, healthcare transformation, agriculture sustainability, and environmental protection. National Science Day highlights the importance of translating research into real-world applications, encouraging entrepreneurship and startup culture within the universities. Today's grand challenges like climate change, pandemics, energy security, demand collaboration across disciplines, institutions, and nations. Science provides tools and evidence needed to achieve sustainable development goals, which ensures a resilient future for humanity. India's achievements in space missions, digital technology, pharmaceuticals, and renewable energy demonstrated that the nation's rising scientific leadership. National Science Day strengthens our resolve towards research, innovation, and societal transformation. With this background of the National Science Day, let me turn my attention to briefly introduce our chief guest, Dr. V.K. Manchanda, who has kindly agreed to deliver the National Science Day Lecture 2026. Dr. Manchanda has made extraordinary contributions in the field of radiochemistry and nuclear science over several decades. He has served as a professor at Sungkyunkwan University, South Korea from 2011 to 2014, strengthening academic collaboration and expanding research in nuclear chemistry at a global level. Earlier, he has served as the head of radiochemistry division at prestigious Baba Atomic Research Center from 2003 to 2011. During this period, he led pioneering research in actinide and fission product separation. Dr. Manchanda's expertise spans chemical quality control of nuclear fuels and innovative materials for radiation detection. His work has had both scientific depth and strategic national importance. He has published more than 400 peer-reviewed international journals, 1,100 conference papers, and 60 innovative lectures. His scholarly contributions are truly exceptional. He has also mentored 20 research scholars, thereby shaping the next generation of nuclear scientists. He is a recipient of the Outstanding Radiochemistry Award in 2017 and was a Fulbright Fellow during his postdoctoral tenure from 1985 to 1987. Dr. Manchanda has rendered exemplary service to the scientific community through leadership roles as President of Indian Association of Nuclear Chemists and Allied Scientists, President of Association of Separation Scientists and Technologists, and now currently he serves as the President of Indian Nuclear Society. Ladies and gentlemen, we are truly privileged to have among us a scientist of such eminence and distinction. On behalf of our university, I extend a heartfelt welcome to you, sir. I welcome Registrar Srimati M.K. Sabita to this occasion. I extend my warmest welcome to all the dignitaries of the dais, all the officers of the universities, all the invitees, syndicate and academic council members, deans, teaching and non-teaching staff, research students, and the media persons. Thank you one and all. Jai Hind, Jai Karnataka.
ಎಲ್ಲರನ್ನ ಹೃತ್ಪೂರ್ವಕವಾಗಿ ಸ್ವಾಗತಿಸಿ ಸಭೆಗೆ ಮುಖ್ಯ ಅತಿಥಿಗಳನ್ನ ಪರಿಚಯಿಸಿದ ಗೌರವಾನ್ವಿತ ಕುಲಪತಿಗಳಿಗೆ ತಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಆತ್ಮೀಯವಾದ ಸ್ವಾಗತವನ್ನ ಬಯಸ್ತೀನಿ. ಮಾನ್ಯ ಕುಲ ಸಚಿವರು ಗೌರವಾನ್ವಿತ ಕುಲಪತಿಗಳಿಗೆ ಸಸಿಯನ್ನ ನೀಡಬೇಕಾಗಿ ವಿನಂತಿಸ್ತೇನೆ. ಬಂಧುಗಳೇ, ಏಷ್ಯಾ ಖಂಡದ ಮೊದಲ ನೊಬೆಲ್ ಪ್ರಶಸ್ತಿ ಪುರಸ್ಕೃತ ವಿಜ್ಞಾನಿ ಚಂದ್ರಶೇಖರ ವೆಂಕಟರಾಮನ್ ಅಥವಾ ಸಿ.ವಿ. ರಾಮನ್ ಅವರ ಬಗ್ಗೆ ಅವರ ದೀರ್ಘಕಾಲದ ಒಡನಾಡಿ ಎ. ಜಯರಾಮ್ ಅವರು ಒಂದು ಕಡೆ ಹೀಗೆ ದಾಖಲಿಸ್ತಾರೆ: ಆಕಾಶಕ್ಕೆ ಆಕಾಶವೇ ಸಾಟಿ, ಕಡಲಿಗೆ ಕಡಲೇ ಸಾಟಿ, ರಾಮರಾವಣರ ಯುದ್ಧಕ್ಕೆ ರಾಮರಾವಣರ ಯುದ್ಧವೇ ಸಾಟಿ ಎಂಬ ಶ್ರೀ ವಾಲ್ಮೀಕಿ ರಾಮಾಯಣದ ಯುದ್ಧಕಾಂಡ that plunged into inquiry and the hands that shaped the future. It honors the scientists whose patience, diligence, and curiosity became the foundations of new discoveries. Today, we have the privilege of celebrating one such scientist, Dr. V.K. Manchanda. For decades, he has stood at the frontier where science and national destiny intersect. He has contributed to institutions that have defined India's atomic journey and represented Indian scholarship with distinction on the global stage. Dr. Manchanda's lecture today on journey of atomic energy in India over the last 70 years carries a unique significance. It is more than a technical discourse. It is a narrative of India's civilizational spirit, a story of evolution of ideas, evolution of perseverance, and evolution of endless possibilities. It is both a privilege and a delight to invite to the lectern a scientist whose life has been intertwined with the very narrative he is about to share with us today. Without further ado, I now humbly request Dr. V.K. Manchanda to address this august assembly.
Respected Professor Loknath, Vice Chancellor, Mysore University, Savita Madam, Registrar, Mysore University, distinguished professors, a very honorable audience. I understand that large number of PG students are also present in the audience. So, Good morning to each one of you. It is a great pleasure to be here in the Mysore University campus on the Science Day. So before I start my Science Day lecture, I would like to pay my respect to the founder, Professor, I will say the architect of civil engineering in India, Professor Visvesvaraya. In fact, I will tell you that I have visited that museum with my family in Bangalore maybe about 40-50 years back, and whatever I saw that, it is etched in my memory till today, and wherever in the world I go, I talk about Professor Visvesvaraya actually. Also, I would like to pay my respect to Dr. Sarvapalli Radhakrishnan, who has been closely associated with this university, then Professor C.N.R. Rao. I think all these giants, I will say they have earned the love and affection not only of the Mysore University but the whole country and the whole world when they got the Bharat Ratna awards. So I like to pay my respect to all the three of them. In fact, the lineage which is started by these great sons of Mysore and India, it is continuing because Professor Loknath informed me that one Professor Meva Singh, he is got the special Prime Minister fellowship this year. So I would like to once again congratulate Professor Meva Singh and also the students and the distinguished professor of this university. Another name which I just now learned is Professor Puttappa. I think it was his efforts in 60s that we got a big campus, Manas Gangotri. So my respect to Professor Puttappa also actually. Then of course, when we are talking of the Science Day, obviously we are talking of another great son of India, Bharat Ratna, Nobel laureate, Sir C.V. Raman. He also has a strong binding with the Mysore state. So I can see this thing for my lecture. Can we go to the slide please? Friends, India celebrates National Science Day on 28th February every year to mark the discovery of Raman effect. And this is, as all of you know, is because of Sir Chandrasekhar Venkat Raman in 1928. See, he was a child prodigy. At the age of 11, he finished his school, and at the age of 18, he finished his post-graduation. And his first research paper, it comes in a journal when he is doing his post-graduation. So can I have the laptop near me? Is it possible? The laptop. Either laptop. This is it's okay, I think. I got it. Hello, hello, hello. Friends, sorry for the interruption. And as all of you may be aware of, that Professor Raman, he was so deeply involved in his research that though at one time for his earning, he had to take up the job of an Auditor General in Calcutta, but his heart always was with science. After finishing his work in his office of the Auditor General, he used to go to a laboratory of the Indian Association of Cultivation of Science. And he was so much involved with his research that he never knew that what time he has to finish his work. At late night he used to come back, and again next morning he will go to his accounts office and then come back to his lab. In 26 he established the Indian Journal of Physics. The Raman effect discovery, as all of you know, was reported on 28th February in a journal, our Indian Journal of Physics, in 1928. And it was this discovery which fetched him the Nobel Prize of Physics, and he was the first national the Nobel laureate in sciences. I don't want to get into the nitty-gritty of the Raman effect, because as I understand from Professor Loknath, we have the audience of very diverse background. Suffice to say, it is a complementary thing to the infrared absorption, whereas in the infrared absorption we look into the change of dipole moment. In the Raman effect, for symmetric molecules we look into the polarizability. The polarizability, if changes, then we get the Raman scattering effect. His various awards and recognitions are listed here, and prominent among them is the 1930 Nobel Prize for Physics, Bharat Ratna in 1954, and Lenin Peace Prize in 1957. These are some of the colleagues of Sir C.V. Raman, who received the Nobel Prize in different disciplines in 1930 in chemistry, medicine and literature. Today we have the bust of Sir C.V. Raman in the garden of Birla Industrial and Technological Museum in Calcutta. Apart from being a very passionate student of science, Sir C.V. Raman also had a lot of leadership qualities. And in 1934 he founded the Indian Academy of Sciences, which is a very prestigious institution. He founded the Rama Research Institute in 1948, where he worked till his last breath. And it is a great honor to the institution to which I belong that he also has mentored the future physicists with the name Homi Jahangir Bhava and Vikram Sarabhai. Now let me turn to the journey of Indian Atomic Energy Program of 7 decades and the role of Indian Nuclear Society, which I am very closely associated today. First Prime Minister Pandit Nehru and Dr. Homi Jahangir Bhava, they set up the Atomic Energy Commission in 1948. And again, very interesting, Dr. Krishnan, who was the student of Professor Raman, was a member of that commission, along with Dr. Shanti Swarup Bhatnagar. DAE was set up under Prime Minister Nehru on August 3rd, 1954. This is another chairman of Atomic Energy Commission, on whose name now the Indian space program is running, Vikram Sarabhai, along with Prime Minister Indira Gandhi, with Cyrus reactor as the backdrop. Now let me turn to the beginning of atomic energy establishment, Trombay, which later changed to Bhabha Atomic Research Center after the sudden demise of our founder Homi Jahangir Bhabha in 1966. See, the cradle of Indian nuclear program is Bhabha Atomic Research Center. Can you believe that an institution which was started in 1954, we have the first reactor Apsara in 1956, 1 megawatt thermal reactor, it was started in 1956. Cyrus, another reactor, 1960. And again you will be surprised to learn that the fuel which goes inside the reactor, half of that was made indigenously at Trombay by the Indian scientists. We had the design validation research reactor Zarlina Purnima, and another crown in the Indian Atomic Energy plutonium plant was set up in 1964, and it is an outstanding indigenous achievement. It has played a very key role in very strategic program of the nation in years to come. See, when India started with a big bang in the early 60s, late 50s, it also had undergone lot of speed breakers. 1974, India did a Pokhran test, and we faced big embargo on nuclear supplies as far as our country is concerned. Once again in 1998, we did Pokhran 2, and again there was an embargo on nuclear supplies. So India was isolated. But with the resilience of the Indian scientists, resilience of the professors of the Indian universities, private industries, that we overcome that one by one. Unfortunately, there were major accidents also, like 3 Mile Island in 1979 in USA, Chernobyl, 1986 in USSR, 2011 Fukushima. So all these were the setbacks. But unfortunately, people remember these minor incidents, but they forget about the big accident that happened in non-nuclear, chemical, fire happened in thermal power station, hydroelectric dam also breached, but people unfortunately put more weightage to anything that happens in the nuclear industry. There were also some speed breakers that at one time solar power was very expensive. Slowly this prices of solar power dropped down. So it became a big challenge so far as the nuclear power is concerned. India faces the limited uranium resources, and also as far as the environmentalists are concerned, I was talking to my friends in the VC office just few minutes back. They were telling there is a threat of environmentalists. So I am here today to appeal to this distinguished member of the audience here, the academician here, that please weigh the truth, don't be carried away by the myths, and the public perception matters a lot. So we must put behind what are the negative images which are widespread and look into the positivities, some of which I am going to talk to you. The caravan of Indian Atomic Energy Program kept moving even on bumpy road. Heavy water program passed through difficult times initially, but since 90s, India is exporting heavy water. Thorax process to recover uranium-233 from thorium, which is going to be a very, very important element in the Indian nuclear program after few years. Please remember thorium. And I appeal to the science student, the physics student, the chemistry student, chemistry professor, please invest in thorium. Please teach about thorium, physical properties, chemical properties, nuclear properties. It is going to be an employment generator after 2 decades for the young scientists. There were several design validation research reactors, Purnima 2, 3, Kamini, and Kamini reactor is running at IG Card today. Our caravan kept moving even on bumpy road. We developed our own reprocessing plant, waste management plants, advanced fuel fabrication facility at Tarapur. Fast breeder test reactor at Kalpakam was set up in 1985. First time in the world, anywhere, a unique mixture of plutonium-uranium carbide had been used. And this reactor has used sodium as a coolant. And the burn-up tells how good that fuel has been. 165 gigawatt days per ton tells it is a fantastic piece of marvel as far as the quality of fuel which has been used, first time indigenously developed in India. And fast breeder test reactor is the cradle for the second stage Indian nuclear power program. Bhavani, which was set up in 2003 to design, construct, commission and operate fast reactors. This year, most likely, we are going to hear about the setting up of first prototype fast reactor in our country. We are today doing the mining of nuclear materials, milling of uranium. We are also having at Hyderabad a nuclear fuel complex where we prepare the nuclear fuel rods. Vendors from large and medium and small industry engineering services within the country played key role in the development and deployment of our reactors by NPCL. See, the nuclear power in India, it was born in 1970, but they learnt all the initial lessons from Cyrus, which is considered the grandfather of nuclear power in our country. And the parents were Tarapur Atomic Power Station 1 and Tarapur Atomic Power Station 2. Can you believe that even today the power is produced by these reactors at less than 1 rupee per unit actually? So because they have old reactors set up long time back, the challenges have been there, but we have overcome the challenges of our 220 megawatt CANDU reactors, and we have mastered the technology from A to Z, and we have come a long way from RAP 1 to RAP 7. RAP means Rajasthan Atomic Power Plant. Now friends, the dark clouds over nuclear industry in the aftermath of Fukushima, they have disappeared. And the world is gearing up to accelerate the contribution of nuclear power to meet the global target of net zero carbon emission by 2050. About 400 reactors are either under construction or are planned and proposed. Incidentally, today we have 400 operating reactors, another 400 are being constructed, planned or proposed. Even in USA, they have taken a decision to increase the nuclear power 4 times, from 100 gigawatt to 400 gigawatt by 2050. Most of the upcoming reactors are in Asian countries. In fact, in UAE, very recently, 4 reactors had been set up with the help of South Korean company, KEPCO. And now the world has recognized, if you want environmentally safe, carbon-free power, which is available 24/7, and it is a base load, uninterrupted supply, nuclear energy is the answer to this. Whatever safety issues are there, whatever nuclear waste issues are there, and which are the concerns of the public, new reactors are being built, and that is called Generation 4 reactors. Another interesting development is there that small modular reactors are also being talked, and many such reactors have been designed and they are available and they are being licensed by various countries. Only there is 2 weeks back there is a news that US Department of Energy and Department of Defense, they transported a nuclear micro reactor of the size of a van on a C-17 aircraft from California to Utah. This is a 5 megawatt reactor. What I am trying to say is that miniaturization is happening. They are demonstrating that it is carbon free. They are also demonstrating that we can set up the nuclear plant at remote places for variety of purposes. To run the AI data center, it is a very, very important contribution. Now look towards India. This is the first time on 15th August 2025, the Prime Minister from the ramparts of Red Fort, he talks about nuclear energy. In 2026 budget, 20,000 crore rupees has been sanctioned by the Finance Minister to set up the small reactors and do the research in that. Very recently in the last budget, last monsoon session, last winter session, sorry, that Shanti Act has been passed, wherein they have made very flexible rules without compromising with the security, safety and safeguard, so that the private players in the country, as they are running other power plants, they can also join the nuclear industry. So the idea is to raise our present nuclear power base from 9,000 to 100 gigawatt. So 8 gigawatt to 100 gigawatt is a jump of almost 11 to 12 times, which also means raising the proportion of nuclear power from 2% to about 9%. I just talked about this. Now these are the various reactors which are running in our country, and at present we have about 9,000 megawatt, 8,800. Another 11,000 megawatt is being constructed, and 32,000 are under various stages of planning. But we need much more because we need to touch 100 gigawatt electricity. These are the 3 different stages of our Indian nuclear energy program. In the first program, first part, we start with natural uranium, and in the second part, we look into the plutonium as the fuel, and in the third, we look into uranium-233, which comes out of thorium. So first is uranium-based, plutonium-based, and third is thorium-based. So these are different stages of our Indian nuclear energy program. Friends, the fact of the matter is India has limited uranium resources but abundant thorium resources. So we have to switch over from uranium to thorium, and in between there will be a stage wherein we will be using plutonium. So there is a scope of having 300 gigawatt for 30 years as far as plutonium is concerned, and when thorium is there, it is an abundant source. We have 500 gigawatt of 500 years. These are some of the reactors which are currently running in India. Now friends, I will like to just tell you that there is no go without nuclear power. Human Development Index depends upon the consumption of power in the country. You can say that per capita consumption and the Human Development Index, if you see worldwide, you will find that the developed nations have got the Human Development Index of 0.9 plus, but they also have per capita consumption of electricity of very close to 4,000. Unfortunately, in India today, we are able to support only to the extent of about 1200. So we need to go almost 3 times. So our current consumption is 1330 kilowatt. We need to increase to 5000 kilowatt. So almost 4 times we have to go, and we need various avenues of energy. Nuclear is one of the prominent candidates, and that is what will make India a Viksit Bharat with a human development index of 0.9 to 0.95. So what we do is, please look into this slide. If you want to generate 10,000 units of electricity, on one hand you need few grams of enriched uranium or few 200 grams of natural uranium, but to get this same result, you have to put 7 tons of coal. So compare the difference. So this 7 tons of coal will give you so much of carbon emission. So that is what actually we are all concerned with. So this bar chart tells you that whereas the nuclear energy will give you only 12 units, 12 gram of carbon dioxide per kilowatt hour of carbon emission, the coal will give you 820 grams of carbon emission. So these are the different stages of producing power: mining, conversion to oxide, fuel, putting them in reactor, getting plutonium out of it, running fast reactor, reprocessing, and waste management. These are the various units of the department. Atomic Mineral Division's head office at Hyderabad and offices at about 10-12 places in the country. UCIL head office in Jadugoda, and again mining and reprocessing at several places. Nuclear fuel complex in Hyderabad. The fuel reprocessing is done at BRC. Waste management, these are very strategic areas. It is done at BRC. R&D support at BRC and IGCAR. And NPCL with head office at Bombay, they produce the power. Heavy Water Board with head office in Bombay produce heavy water. And ECIL is responsible for the reactor control and instrumentation. So the key to all that, which I want to bring to the notice of this distinguished audience, is uranium-235, which is 0.7% available in nature. That is the key which is driving it. Thorium, as it is, it cannot be used as a fuel, it has to be converted. Uranium-238 cannot be used as a fuel, it has to be converted. But 235 is the starting material. So what we do is, we convert 238 to plutonium-239 and thorium-232 to uranium-233. So when we put this fuel in the reactor, it is in the form of these pellets, and you can consider pellets as broken our chalk pieces, chalk that we write on the blackboard. If you just break that chalk to 3-4 pieces, that is how the pellet looks like. And these pellets are put in the tubes, and these tubes are made of special material called zircaloy, and these tubes we make the bundles, and these bundles are put inside the reactors. And after the fuel is used in the reactor, it has to be removed periodically, and it is so hot radioactively and also temperature wise, you cannot leave it outside. It has to be put in the storage bay. It is under water for several years before it is temporarily shifted to the dry cast in isolated places. I must say that world-wise today, one of the problem is how to dispose nuclear waste. In country like America, which has the biggest nuclear power program with 100 gigawatt electricity, they have 100,000 tons of such spent fuel lying around the utilities where various reactors are there. 10-15 years back, they had made a plan to put it in geological repository in Nevada and Yucca Mountain, but due to political pressure, they have to hold it. Now still the world is facing a problem with respect to the disposal of the spent fuel, but India is many regards ahead. Maybe we can discuss it later because the time does not tell, because we do the reprocessing, we reduce the size of spent fuel. So it is a big advantage so far as India is concerned. As I told you, we have large thorium resources, relatively small uranium resources, and the key isotope uranium-235 is only 0.7%. Once again, it gives you some idea about the thorium resources India has got. Perhaps India has got one of the largest thorium resources. Please distinguish between uranium and thorium. India is very poor in uranium resources, but relatively rich in thorium resources. But thorium cannot be used straight away for nuclear power production. We have to convert it to the fuel form, then only it can be used as a fuel. Now let me turn to the other benefits, societal benefits of the atomic energy. It is not only helps in producing electricity, it helps in various ways to run our national security, environment, health, food, water, etc. These are some of the areas where radioisotope and radiations are helping the country and the society at large. Board of Radiation and Isotope Technology at Vashi, Navi Mumbai. This has got a plant where the radiopharmaceuticals are produced and sent to more than 550 hospitals in our country for diagnostic and therapy purposes. These radioisotopes, though they are produced inside BRC, but they are converted to radiopharmaceuticals in Board of Radiation and Isotope Technology plant at Vashi, New Bombay. There is a plant to do the sterilization of the food items and medical products at Vashi. The applications that we have in the healthcare are in radiopharmaceutical, radionuclide imaging, radioimmunoassay, radiotherapy, sterilization of medical products, and blood irradiation. When I joined Bhabha Atomic Research Center few years after that, a plan was set up at Southgate. Those of you who have visited Bhabha Atomic Research Center may know that today the entry is through North Gate, but those days used to be from Southgate, where our Tata Thermal Power Station there, or RCF fertilizer industry is there. So from that end, when you enter BRC, once plant was set up with the name ISOMED. And friends, it is a great pride moment for me to tell you, it has worked for almost 40 to 45 years, serving the pharmaceutical industry in Bombay and around Bombay in Maharashtra, wherein cobalt-60 was used as a source, and it has helped in sterilization of variety of medical products. And some of the items I have listed here: hospital supplies, family welfare products, personal hygiene products, pharmaceutical raw materials, disposable medical devices, pharmaceutical products, veterinary products, sutures, cosmetics, Ayurvedic finished products. The radioisotopes which are commonly used for our both diagnosis and therapy purposes: iodine-131, yttrium-90, phosphor-32, samarium-153, iodine-131. Technetium-99m is the workhorse, and these are some of the isotopes which are used for diagnostic purpose. And also, many of you will be very happy to learn that the radiations are being used in agriculture sector in a big way. So I will take few minutes to give you the glimpses of the areas in which the radiations are being used in the agriculture sector. So the process of crop improvement using radiation is called mutation breeding. At BRC, 72 varieties have been developed through mutation in 15 different crops, 31 in oilseed crops, 24 in pulse crops, and 17 in cereal, millet, fiber, and fruit crops. So some of the crops which are being used for mutation breedings I have listed here: groundnut, mustard, soybean, linseed, sunflower, jute, rice, wheat, urad bean, mung bean. In fact, one of our chairmen while addressing the gathering like this, he informed us few years back, when you go to a Udupi restaurant, then he informed that the urad dal which is used in the idli there, one of the two idli, it comes from the variety of urad where the seed is provided by the Bhabha Atomic Research Center. So this is a great tribute to the nuclear agriculture scientists of the Department of Atomic Energy. Very recently, in the list has been added fruits. The first fruit is the most loving fruit, I think all over India, including Mysore, banana. So a dwarf variety of banana has been grown through the mutation breeding route. Now, what is the advantage of this? It improves the yield, it helps in the pest and disease resistance, also the drought salinity and temperature, etc., heat and cold, it withstands, and the quality where the iron and zinc biofortification helps, high protein content, and oil quality, quantity and quality both improves. And this all happens because of the cobalt-60 gamma rays or electron beams. These are now, I think this is what I was just now mentioned to you, a new variety of banana has been now developed at Bhabha Atomic Research Center using the gamma radiation. Now the work has started in variety of flowers also. So some of the flowers I have just shown you. Now work is going on. The idea is you can choose the color, you can increase the size, it will be grown faster, yield will increase. These all benefits are going to come, and some of the evaluation of the mutants is happening in Solan in Himachal Pradesh. There are a large number of irrigation plants which are helping in the export also of some of the high value products, and also in the increasing the shelf life of some of the food items. So these are some of the companies which are using electron beam and cobalt-60 for increasing the shelf life or doing some variety of job using radiations. In Lasselgaon, a plant was set up in 2003 for increasing the shelf life of onion. Okay friends, I will like to take 5 minutes to give you some idea about the association I am working today for. It is known as Indian Nuclear Society. It is a registered professional body of nuclear scientists and engineers and technologists in India with its headquarters at Mumbai, and it has branches at Hyderabad, Kalpakam, Rawatbhata, Narora, and also Mysore. The society was inaugurated in January 88 by late Shri J.R.D. Datta. The core strength of INS is a large pool of experts with decades of experience in nuclear science and technology. This is the picture of the inauguration program, where you can see in the middle Shri J.R.D. Tata. You also have M.R. Srinivasanji. He also belongs to Karnataka. He passed away, I think, almost a year back. We have Dr. P.K. Iyengar there, who was earlier our chairman, Atomic Energy Commission. The mission of the INS is to collaborate with government agencies, educational institutions, and other organizations for advancement of knowledge and technology pertaining to nuclear science. What are the activities we are involved in? Outreach program for all sections of society, poster competition, national international conferences, INS awards, INS foreign travel grant scheme, INS newsletter, colloquium, training, and center of excellence we want to set up in nuclear science and technology. INS looks forward to the support of the professors and the young students present here to pursue these activities. They can join INS and support the activities. Very recently, we had a program, outreach program for the defense veterans. You can see in the picture many gallantry award winners of the defense forces. They participated in our program. This is a picture of the poster competition we had some time back involving the students. Hundreds and thousands of students, they contributed to the posters. We also conduct our annual conferences. Sometimes the President and the Prime Minister of the country, they have participated in our program to give away the awards we call INS Lifetime Achievement Awards. So we had seen earlier the President of the country and as well as the Prime Minister Atal Bihari Vajpayee, now Prime Minister Manmohan Singh is giving the awards to the Lifetime Achievement Award of INS. These are some of the lectures being delivered on the safety culture in nuclear science. We recently had a theme meeting in Navi Mumbai where we called the representative of the private industry who had a lot of curiosity about how to set up a nuclear power plant, how do we deal with the safety issue, how do we deal with the radiation issue. So we gave them lectures by the experts for 2 days. Very recently, just last week only, I have returned from Central University Punjab in Batinda, where we had a similar program, and where not only we gave the lecture, but we also asked the students to carry the mission of Indian Nuclear Society all over the campus. So they took out a rally with some of the posters which they have made. So I will like to thank at the end, once again, Professor Loknath for giving me the opportunity to talk to this distinguished audience. And thank you very much for the patient hearing.
Thank you so much, sir, for the truly enlightening lecture. The insights you have shared from decades of your experience have given us a deeper appreciation of the process that have shaped our nation's scientific landscape. On behalf of the University of Mysore, it is now my privilege to invite our Honorable Vice Chancellor and Registrar to felicitate Dr. V.K. Manchanda on this occasion. Thank you, dignitaries, for doing the honors. ಇಂದಿನ ಕಾರ್ಯಕ್ರಮವನ್ನು ಅಚ್ಚುಕಟ್ಟಾಗಿ ಆಯೋಜಿಸುವಲ್ಲಿ ಅಪಾರವಾಗಿ ಶ್ರಮಿಸಿರುವ ಮಾನ್ಯ ಕುಲಸಚಿವರಾದ ಶ್ರೀಮತಿ ಎಂ ಕೆ ಸವಿತಾ ಅವರು ನಮ್ಮೊಂದಿಗಿದ್ದಾರೆ. ಜನಸ್ನೇಹಿ ಕೆಎಎಸ್ ಅಧಿಕಾರಿಯಾಗಿ ತಾವು ಕಾರ್ಯನಿರ್ವಹಿಸಿದ ಕಡೆಯೆಲ್ಲ ಅಚ್ಚಳಿಯದ ಹೆಗ್ಗುರುತನ್ನು ಮೂಡಿಸಿದ ಶ್ರೀಮತಿ ಸವಿತಾ ಅವರು ಇತ್ತೀಚೆಗಷ್ಟೇ ಹಿರಿಯ ಶ್ರೇಣಿಯಿಂದ ಆಯ್ಕೆ ಶ್ರೇಣಿಗೆ ಪದೋನ್ನತಿಯನ್ನು ಹೊಂದಿದ್ದಾರೆ. ಮಾನ್ಯ ಕುಲಸಚಿವರಿಗೆ ಸಮಾರಂಭದ ಯಶಸ್ಸಿಗೆ ಕಾರಣಕರ್ತರಾದ ಸರ್ವರಿಗೂ ವಂದನೆಗಳನ್ನ ಸಲ್ಲಿಸಬೇಕಾಗಿ ವಿನಂತಿಸ್ತೇನೆ.
Respected Vice Chancellor, distinguished Chief Guest, deans, professors, esteemed scientists, beloved teachers, dear colleagues, and my dear students. ಎಲ್ಲರಿಗೂ ನನ್ನ ನಮಸ್ಕಾರಗಳು. ಈ ದಿನ ರಾಷ್ಟ್ರೀಯ ವಿಜ್ಞಾನ ದಿನದ ಅಂಗವಾಗಿ ಕಾರ್ಯಕ್ರಮ ಹಮ್ಮಿಕೊಂಡಿದ್ದು, ಇತ್ತೀಚೆಗೆ ಒಂದು ಪ್ರಜಾವಾಣಿ ಆರ್ಟಿಕಲಲ್ಲಿ ಸಿ ವಿ ರಾಮನ್ ಅವರ ಬಗ್ಗೆ ಓದಿದಂತಹ ಎರಡೆರಡು ಮಾತುಗಳನ್ನು ಹೇಳಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀನಿ. ಸಿ ವಿ ರಾಮನ್ ಅವರು 1930 ಡಿಸೆಂಬರ್ 10 ಸ್ವೀಡನ್ನಲ್ಲಿ ಸ್ಟಾಕ್ಹೋಮ್ನಲ್ಲಿ ಅವರು ನೊಬೆಲ್ ಪ್ರಶಸ್ತಿಯನ್ನು ಸ್ವೀಕರಿಸುವಾಗ ಇಡೀ ಸಭಾಂಗಣದಲ್ಲಿ ಚಪ್ಪಾಳೆಯನ್ನ ಸುರಿಸ್ತಾ ಇದ್ರೆ, ಅವರು ಕಣ್ಣೀರು ಸುರಿಸ್ತಾ ಇದ್ರಂತೆ. ಯಾಕೆಂದ್ರೆ 1930 ಇನ್ನೂ ಸಹ ಸ್ವಾತಂತ್ರ್ಯ ಬಂದಿರಲಿಲ್ಲ. ಅವರ ಸುತ್ತ ಬ್ರಿಟಿಷ್ ಫ್ಲಾಗ್ಗಳು, ವಿದೇಶಿ ಧ್ವಜಗಳು ಹಾರಾಡ್ತಾ ಇದ್ವಂತೆ. ಆದಾಗ್ಯೂ ಅವರ ಅಚಲ ನಂಬಿಕೆ ಹೇಗಿತ್ತು ಅಂತ ಹೇಳಿದ್ರೆ, ಅವರ ಅನ್ವೇಷಣೆಗೆ ನೊಬೆಲ್ ಅವಾರ್ಡ್ ನೋಟಿಫೈ ಆಗೋಕ್ಕೂ ಮೊದಲೇ, ಸುಮಾರು 5 ತಿಂಗಳ ಮೊದಲೇ ಅವರು ಸ್ವೀಡನ್ನತ್ತ ಹಡಗಿನಲ್ಲಿ ಪ್ರಯಾಣ ಬೆಳೆಸಿದ್ರಂತೆ. ಇದು ಅವರ ಅಹಮ್ಮನ್ನ ತೋರಿಸಲ್ಲ, ಅವರಿಗೆ ಇದ್ದಂತಹ, ಅವರ ಅನ್ವೇಷಣೆಯಲ್ಲಿ, ಅವರ ಕೆಲಸದಲ್ಲಿ ಇದ್ದಂತಹ ಶ್ರದ್ಧೆಯನ್ನ ತೋರಿಸುತ್ತೆ. ಜೊತೆಗೆ ಅವರು ಆ ದಿನನೇ ಕರೆ ಕೊಟ್ರಂತೆ, ಭಾರತದ ವಿಜ್ಞಾನಿಗಳು ನಾವು ವಿದೇಶಿಯರ ಪರಂಪರೆಯನ್ನ ಅನುಸರಿಸಬಾರ್ದು, ನಮ್ಮಲ್ಲಿರ್ತಕ್ಕಂತಹ ಸಂಪನ್ಮೂಲಗಳ ಮೂಲಕನೇ ಪ್ರಪಂಚವನ್ನ ಭಾರತದತ್ತ ನೋಡುವಂತಹ ಅನ್ವೇಷಣೆಗಳನ್ನ ಮಾಡೋದ್ರ ಮೂಲಕ ನಮ್ಮ ದೇಶದ ಘನತೆಯನ್ನ ಎತ್ತಿ ಹಿಡಿಯಬೇಕು ಎನ್ನುವಂತಹ ದೇಶಾಭಿಮಾನವನ್ನ ಅಪಾರವಾಗಿ ಹೊಂದಿದ್ರು ಸಿ ವಿ ರಾಮನ್ ಅವರು ಅನ್ನೋದನ್ನ ಓದಿದ್ದೆ. ಜೊತೆಗೆ ನೊಬೆಲ್ ಅವಾರ್ಡ್ ವಿಜ್ಞಾನ ವಿಭಾಗಕ್ಕೆ ಬಂದು ಇನ್ನೇನು 2 ವರ್ಷ ಹೋದ್ರೆ, 1928 ಅಂತ ಹೇಳಿದ್ರೆ 2028 ಬಂದ್ರೆ ಸುಮಾರು 100 ವರ್ಷಗಳು ಆಗ್ತಾ ಇದೆ. ಆದ್ರೆ ಇಂತಹ ಒಂದು ನೊಬೆಲ್ ಅನ್ನ 100 ವರ್ಷಗಳ ಹಿಂದೆ ತಂದಂತಹ ಸಿ ವಿ ರಾಮನ್ ಅವರು ಅವತ್ತಿಗೆ ಬರೀ ಬೆಳಕನ್ನ ಆಧಾರವಾಗಿಟ್ಟುಕೊಂಡು ಇಷ್ಟು ದೊಡ್ಡ ಸಿ ವಿ ರಾಮನ್ ಎಫೆಕ್ಟ್ ಅನ್ನ ಒಂದು ಅನ್ವೇಷಣೆಯನ್ನ ಮಾಡಿದ್ರು. ಅವರು ಬಳಸ್ತಿದ್ದಂತೂ ಕೇವಲ 500 ರೂಪಾಯಿ ಅಂತಹ ಇಕ್ವಿಪ್ಮೆಂಟ್ಸ್ ಮತ್ತೆ ಕನ್ನಡಿಯಂತಹ ಸರಳ ಉಪಕರಣಗಳನ್ನ ಬಳಸಿ ಅವರು ಅನ್ವೇಷಣೆಗಳನ್ನ ಸದಾ ಮಾಡ್ತಾ ಉರುದಿಮಿಸ್ತಾ ಇದ್ರಂತೆ. ಜೊತೆಗೆ ಇನ್ನೆಷ್ಟು ವರ್ಷಗಳು ಕಾಯಬೇಕು ನಾವಿಂತಹ ಒಂದು ನೊಬೆಲ್ ಅವಾರ್ಡ್ ಅನ್ನ ಪಡಿಬೇಕು ಅನ್ನೋದಾದ್ರೆ ಅನ್ನುವಾಗಲೇ ಗೊತ್ತಾಗುತ್ತೆ ಸಿ ವಿ ರಾಮನ್ ಅವರ ಕೊಡುಗೆ ಎಂತದ್ದು ಅಂತ. ಹಾಗಾಗಿ ಆ ಸಿ ವಿ ರಾಮನ್ ಎಫೆಕ್ಟ್ ದಿನದ ಅಂಗವಾಗಿ ಈ ರಾಷ್ಟ್ರೀಯ ದಿನದ ಆಚರಣೆಯ ಸಂಭ್ರಮ. I would like to present my vote of thanks. It is indeed a great honor and privilege to stand before you to deliver the vote of thanks on behalf of the organizing committee for today's National Science Day 2026 with the theme Journey of Atomic Energy in India of last 70 years celebration at our esteemed University of Mysore. First and foremost, I extend my heartfelt gratitude to our chief guest, Dr. V.K. Manchan, former head Radiochemistry Division, Bhabha Atomic Research Center, Mumbai. Sir, I hope that your elaborate presentation helps to our faculty and students. Your gracious presence and your enlightening address have enriched this program immensely. Thank you, sir. Your journey in atomic science, marked by dedication, research excellence, and service to society, stands a shining example of how science transforms lives in India. Sir, also I would like to extend my heartfelt gratitude to our chief guest wife, being present here, Srimati wife Savita Manchan. Thank you for your gracious presence, ma'am, along with sir. And also I would like to thank to sir, friends and neighbors also presenting here. I sincerely thank our respected Vice Chancellor, Professor Loknath N.K., for his visionary leadership and unwavering support to fostering a culture of research, innovation, and academic excellence within our university. Under his guidance, platforms like today's celebration become meaningful opportunities to nurture scientific temper among students. Sir, thank you for your all support, sir. My sincere thanks to the syndicate members, AC members, chairpersons of the different departments, deans and directors, and coordinators, especially the students from Maharaja College, Yuvaraja College and the Gangotri campus. Your presence reflects a shared commitment to celebrating science and invaluable role in national development in this occasion. I would also like to acknowledge the tireless efforts of the organizing committee, faculty coordinators, research scholars, and student volunteers who worked diligently to ensure that today's program was both informative and inspiring. As we conclude this National Science Day program, let us renew our pledge to uphold scientific temper, embrace innovation, and contribute meaningfully to society through knowledge and research. Let us remember that science is not confined to laboratories. It lies in every question we ask and every problem we strive to solve it. Thank you, one and all, and happy Holi.
ತಮಗೂ ಧನ್ಯವಾದ ಮೇಡಮ್. ಇಂದಿನ ಕಾರ್ಯಕ್ರಮವನ್ನು ರಾಷ್ಟ್ರಗೀತೆಯೊಂದಿಗೆ ಮುಕ್ತಾಯಗೊಳಿಸ್ತಾ ಇದ್ದೀವಿ. ದಯಮಾಡಿ ಎಲ್ಲರೂ ರಾಷ್ಟ್ರಗೀತೆಗೆ ಗೌರವ ಸೂಚಕವಾಗಿ ಎದ್ದು ನಿಲ್ಲಬೇಕಾಗಿ ವಿನಂತಿ.
ಭಾರತ ಭಾಗ್ಯ ವಿಧಾತ ಪಂಜಾಬ ಸಿಂಧು ಗುಜರಾತ ಮರಾಠ ದ್ರಾವಿಡ ಉತ್ಕಲ ವಿಂಧ್ಯ ಹಿಮಾಚಲ ಯಮುನಾ ಗಂಗ ಉಚ್ಚಲ ಜಲಧಿ ತರಂಗ ತವ ಶುಭಮೇ ಜಾಗೆ ತವ ಶುಭಾಶಿಷ ಮಾಗೆ गाहे तव जय गाता जयक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
ಕಾರ್ಯಕ್ರಮ ಇಲ್ಲಿಗೆ ಪರಿಸಮಾಪ್ತಿಗೊಂಡಿರುತ್ತೆ. ಧನ್ಯವಾದಗಳು.